after the Pioneers launched and were very successful, in the very beginning of the 1970s, and were able to fly by and work just fine, NASA realized that sure enough, the Grand Tour idea was going to work. Again, Mariner 11, Mariner 12, which they renamed Voyager 1 and Voyager 2, were launched, and they were launched on actually quite a large rocket. So what we have here is that we have a Titan missile, and on the side of it are two pretty sizable rockets strapped to the side, and a Centaur rocket sitting on top of it. And so the trio on the bottom launched this thing up, and then the Centaur launched it to push it on. The Voyagers were much, much heavier spacecraft than the Pioneers. They had far more equipment on board. They had a much, much, much more robust RTG to provide electrical power. Voyager 1 and Voyager 2 were launched. Now, ironically, Voyager 2 was launched first, and Voyager 1 was launched a few weeks later. Now, the reason for this is that Voyager, that they took slightly different paths. One had a little bit farther to go than the other because of when they were launched. And ironically, Voyager 1 arrived at Jupiter first, and Voyager 2 a little bit later, even though Voyager 2 launched first. Its orbit actually took it a little bit longer to get there. NASA also did a plaque type thing on it, similar to what they did on the Pioneers from the previous lecture, except that they learned their lesson here about the public relations sort of thing, and instead they put a LP on board. And now LP, this is like a vinyl record, except it was metal and had recorded on board a greeting and then children saying hello in languages, many different languages that were spoken on Earth, had greetings from various world leaders, had sounds of Earth. So it had the sound of the wind blowing, and brooks and rivers and streams and birds and various animals and some music, the kind of music that we listen to and so forth. So all that was on this record, so that, I suppose any aliens that find it could put it on a turntable and listen to it. Well, not knowing if people knew what to do, they actually stuck a little plaque over it that had on the plaque a picture of a turntable with a stylus on it, giving instructions here. The idea that it spins at a certain rate. They tried to get the spin rate down that it's supposed to be turning at. You can't say 33 and a third RPM because they wouldn't know how to read that, or what a minute would be, which is a human designation. So they're trying to put it in terms of physical constants as to how many times it's supposed to turn, and then they had a similar sort of thing to the Wayfinder from the Pioneers in terms of distances to various sort of things, and so. And then attempts at explaining what does DNA look like and so forth. Now, whether any aliens would actually figure this out, I have no clue. But again, the chance of it ever being found is next to nothing. So really, this is more for our benefit to say that, hey, we've put something out there that will outlive us. That's kind of more for our benefit, for public relations benefit, rather than the likelihood of anyone actually finding it. So Voyager 1 was launched and flew from Earth to Jupiter. Jupiter tossed it to Saturn. And as I said in an earlier lecture, we sacrificed Voyager 1 because we let it sling in such a path that we got to study the rings of Saturn very closely. And Voyager 2 was tossed from Saturn to Uranus and from Uranus to Neptune. And so Voyager 1 studied the rings of Saturn. Voyager 2 studied Uranus and Neptune. Both of them studied Saturn and Jupiter. Those are the two biggest things that are out there, and the things that we thought we needed to study the most. Afterwards, we realized that Uranus and Neptune are really far more interesting than we originally had thought that they would be. And so we now kind of, some people were wondering if maybe they should have both gone, if we should have sacrificed the study of the rings in order to study Uranus and Neptune more. But that the decision, you don't really know until after you do it what's going to be the best thing to do. Okay, so here they are, some timelines as to when they were launched. And again, they were launched in 1977. They made it to Jupiter pretty quick, 1979, so just a couple years. Got to Saturn in 1980 and 1981, so just a year or two more. But it took a long time because the outer solar system is really spread out. It took until 1986 to arrive at Uranus. I'd already started graduate school by that point. And so remember teaching astronomy labs when we were getting the first things back from Uranus. And then it flew on to Neptune in 1989, and this was, I think, one of the early semesters that I was teaching astronomy, teaching the lecture, and it was like, as this thing was flying by, we're getting real time some of the information back from Neptune, which we were seeing for the very first time, and so, but I think you had to launch something in 1977, and it has to still be running 11 years later in August of 1989. And again, they had never expected any spacecraft to last for that long. But this is what had to be done for the Voyagers. That was not the last spacecraft that was launched to the outer solar system. We've already talked about New Horizons. New Horizons was launched and flew by Pluto and then out to visit the other Kuiper Belt object. So, spacecraft leaving the solar system. In 2016, I got this graphic right here from a place called heavensabove.com. It's really a wonderful website that tells you all about satellites. If you want to go out and look at satellites, there's a lot of satellites you can see with the naked eye, but it also has this thing that tells you where the spacecraft are that are leaving the solar system. And so that's where they were in November of 2016. That's where they were in April of 2018. That's where they were in October of 2018. That's where they were in November of 2019. And you notice they've been gradually getting farther and farther out. Then I got the same from the same site, but then the problem is the very next one is for this year, 2020, but you notice that some of these Pioneers and Voyagers are right at the edge of that screen. So for this year, they actually had to change the scale of the drawings. So that's why they look like they jump backwards a little bit. But they are all leaving the solar system. They're all of them well past the farthest planet. New Horizons is the closest in. It's still almost 49 AU away from us. All the other things that are out there are well over 100 astronomical units away. That is actually taking them into interstellar space. And Pioneer 10, first thing tossed out, 127 AU. It slowed. It was going much faster than that prior to this, but as it gets further and further out, gravity slows it down a little bit, pulling back from the sun. Pioneer 11. Now, neither of those Pioneers still work. Even though we got 5 spacecraft leaving the solar system, 2 of them, Pioneer 10 and Pioneer 11, no longer operate. They have failed. They have gotten out so far. They were launched so long ago, early 1970s. The RTGs no longer provide power, and they have not provided power for a very long time. And so they have ceased functioning. We've lost contact with them. They don't have enough power to operate. Voyager 1 and Voyager 2 also have RTGs powering them, but their systems are a little bit more robust, and so they are providing a little bit more power. Nonetheless, they are at the very end of their operational lives. it's expected that within the next couple of years or so, they may have difficulty providing enough power from the RTGs to operate the spacecraft at all. So right now they've turned off almost all the instruments on board. They can only operate like one thing at a time, and really there's not a whole lot for it to see out there. But it is actually collecting data, which it does send back to Earth now and then. New Horizons, likewise, is going to eventually get out that far. At the time New Horizons launched, it made a lot of publicity as being the fastest thing leaving Earth ever. But it would slingshot past Jupiter. But unlike the others that were slingshot past Jupiter and Saturn, it did not go by Saturn, so it did not get that extra gravitational boost, and so that means that it has been slowing, is now no longer the fastest thing leaving the solar system. That goes to Voyager 1. Voyager 1 is definitely the fastest thing leaving the solar system. It is moving at 17 kilometers per second. Over 150 AU from us, and so that is the farthest thing and the fastest thing. While those five, Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons have all visited the outer solar system, others have been out there too. Ulysses went past Jupiter into an orbit and allowed it to study the sun from the north and south poles. Galileo was a spacecraft actually sent to Jupiter, as was more recently the Juno spacecraft, which was launched toward Jupiter. And the Cassini spacecraft was sent to Saturn. Well, we couldn't get it directly to Saturn, so we sent it to Jupiter and let Jupiter toss it to Saturn.